All right, for our second video on section 3, we're just going to go over 3 examples of how this information looks or how it's going to work. Again, remember, if you have the scale factor of your two lengths, that's the same as the scale factor of the perimeters. If you have the scale factor and you square it, that's the same as the scale factor of the areas. So areas, you'd square the scale factor. Same thing if you have your scale factor and you cube it, that's the scale factor for volumes. So if we have two triangles, ABC, which is similar to triangle MNP, and we know that the perimeter of ABC is 150 units. Part A, what is the perimeter of MNP if MNP is 3 times larger? Well, perimeter is the same scale factor as the regular scale factor. So if this perimeter is 150, we would just do 150 times 3, because MNP is 3 times larger. So it would be 450 units. Whatever that is, centimeters, feet, inches, all the way around ABC is 150 of them. MNP is 3 times larger, so all the way around MNP is 450 units. MNP has an area of 48 units squared. So what is the area of ABC? Well, again, we're going to use this information that is 3 times larger. That's kind of our scale factor. If the scale factor is that it's 3 times as big, that means the ratio of the areas is our scale factor squared, so 3 squared, so it's 9. The areas are going to be 9 times as big. Remember, this MNP is our bigger one. This one should be 9 times as big as this one. Area of MNP is 9 times as big as the area of ABC. We can kind of flip that around and say, so the area of ABC is 1/9 times as big as the area of MNP. So we would just take our 48, that's this units here, times it by 1/9, and we'd get 5 1/3 units. Or you can do 5.3. Remember, this is, oops, I should say it's units squared. Because it is an area, it's units squared. So that would be the area of triangle ABC. Example 2. The volume of a cylindrical can is 210 units cubed. What is the volume of a similar can that is half as tall? So if we had a one pop can that is pretty darn big, 210 units cubed, and we had a similar pop can that looked exactly like it, but it was half of the size. It was half as tall, half as wide, half all of those measurements. That means our scale factor is 1/2 times as big. We want to find the volume of the smaller can, though. Ratio of volumes is our scale factor cubed, so that's 1/2 cubed, which means we're doing 1/2 times 1/2 times 1/2. That's what cubing means. It's times itself 3 times. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the ratio of our volumes is 1/8. The volume of the smaller can is going to be 1/8 times as big as the volume of the larger can. That's what this is telling us. So we would just take this volume, 210, times it by 1/8, and we get that the volume of the smaller can is 26.25 units cubed. That would be how to find the volume of a smaller can. Example 3. Figure 1 has a volume of 5 units cubed and a surface area of 4 units cubed. Figure 2 has a volume of 40 units cubed. If figure 1 and 2 are similar, what is the surface area of figure 2? So we can use our ratio of volumes. This one is 5, this one has 40, so it's 5 to 40. Or we can reduce that and become 1/8. This is our ratio of volumes. Figure 1 has 1/8 of the volume of figure 2. The ratio of volumes, this red number, 1 to 8, 1/8, equals our normal scale factor cubed. So to get our scale factor alone, we would take the cubic root. This is going to be similar to taking a square root. On your calculator, you'll find a button that has a little 3 right next to the square root sign. This is a cubic root. It means what number times itself 3 times gives you this number. So we would take the cubic root of both sides. That's how we'd get rid of this cubed. So it's just scale factor over here, and it's cubic root of the ratio of volumes over here. That would look something like this. Cubic root of 1/8 equals 1/2. Because 1/2 times 1/2 times 1/2 equals 1/8. So 1/2 is our regular scale factor, is what that's saying. Our scale factor squared is the ratio of areas. We can do that over here then. 1/2 squared is 1/4. So these two, if figure 1 has an 1/8 of the volume of figure 2, it should have a 1/4 of the surface area. Surface area of figure 1 is 1/4 times as big as the surface area of figure 2. Flipping that around, surface area of figure 2 is 4 times as big as the surface area of figure 1. So since it's 4 times as big, and this surface area was 4, we would do 4 times 4. So we'd find out that the surface area of figure 2 is 16 units squared. And that'll wrap it up for our section 3.